All right, so new flavor with the We Do problems is we've got product rule and quotient rule going on a couple times. So you'll notice this first term we've got two functions being multiplied, and with the second term we've also got two functions being multiplied. So we've got two spots where we're going to apply the product rule. So the first one I'll do in blue. Our f is y, our derivative of f is 1 dy dx. Our g is e to the y. E to the y stays the same, so our derivative of g, e to the y, and then we did the derivative of y expression, so we need a dy dx. Plug into your product rule. And I'm just going fast, so I'm not going to write all of the x's in my expression, like g of x, f prime of x. Just going fast. So try to keep up at this breakneck speed. All right. That's a y. So we've got that one, so we can write that down, dy dx. E to the y plus y e to the y dy dx. Then we need to look at our green one, our next one. I'll do that in green. This Kermit color here. This one mercifully doesn't have any y's in it. So if we plug into that product rule, I've got 6e to the x plus 6x e to the x. So I've got plus 6e to the x plus 6x e to the x. And then the derivatives after that, we've got 5y, so that's just going to be 5 dy dx. And then we've got 2y to the fourth, so that's going to be 8y to the third dy dx. And I'm just going to erase this because we don't need it anymore. We already used that stuff, so get out of town. So move our terms around. No like terms. So we're just going to go down the line here. On the left-hand side, we're going to pull out our common factor of dy dx. Divide both sides by this long thing. And then we call it a day. We've got our answer. All right, next up we've got the quotient rule going on. So that would be right here, we've got f over g. So f equals 15y, g equals 2x, derivative f, 15 dy dx. Derivative g, 2 chain, whoa. Quotient rule. We've got f prime, which is 15 dy dx, times g 2x minus g prime and f, so 15y times 2, divided by g of x squared, which is going to be 4x squared. Right. So if we follow this through, we've got 30x dy dx minus 30y over 4x squared. All right, so we're going to write that over here. Then we've got derivative 16x, which is 16, and derivative 2 is 0. So I need some space. Just erase some of that. All right, in order to solve for dy dx, we need to get rid of that fraction. So we're going to multiply both sides by 4x squared. Well, everything by 4x squared. So this cancels. 4x squared and 0 is 0. So I've got 30x dy dx minus 30y minus 4 times 16, 64 squared. Move our terms. So once you get the hang of this, it just kind of gets tedious. All right, 2 more. Let's zip on through these. So this is the form a to the x. So our derivative of that is x Lena. So I've got 2 to the x, natural log of 2, plus derivative 6 is 0. Derivative of y is dy dx. Derivative of 4y squared. Pull down the exponent, we've got negative 8. And then make it one smaller, be y. Tack on your dy dx. Rather than move stuff to the left and to the right, I'm just going to go ahead and keep my dy dx's since they're on the same side already. And factor out. And there we have it. All right, last one. We've got the product rule happening at this first one, f and g. Derivative 15 sine x, 15 cosine x. Then we have our g, cosine y. Derivative of cosine y is negative sine y. And then we did the derivative of a variable expression with y, so we need to do dy dx. Substitute into our product rule. Whoopsie. Might be making hella mistakes this fine day. All right, so we can't combine them into cosine squared because their guts aren't the same. So now we're going to take this lovely derivative and substitute it in over here. So I've got 15 cosine x cosine y minus 15 sine x sine y dy dx. Derivative of 16x is 16 equals derivative of 23 tan x is 23 secant squared x. All right, move 15 cosine x cosine y to the other side because it doesn't have a dy dx. Then we have to move the 16 as well. None of them are like terms. I need more space. And I forgot my dy dx here. Divide both sides by that negative 15 sine x sine y. And there we have it.